Hello everyone, how are you? This is Dr. Ranjodh Singh. In the previous lecture, we discussed the basic concept of the disasters, their types, causes, and the importance. Today, we will continue from the foundation and move towards the next important phase of the disaster management, which is resilient infrastructure. In this lecture, we will focus on understanding how disaster can be managed, how they can be prepared, how mitigation measures and resilient infrastructure practices can be incorporated. As future engineers and professionals, it is important for us to understand the disasters, their impacts, and how they can be prevented. But their impacts can be definitely be reduced through scientific planning, technology, community participation, and sustainable development. So by the end of today's lecture, you will be able to understand the disaster management cycle, resilient infrastructure, resilient structures, different techniques that can make a resilient infrastructure, to identify a role of engineers in disaster risk reduction. So let's begin today's lectures with an important question. Why do some communities recover quickly after disaster while others taking years? This question will guide our discussion throughout the session. So let's begin. First of all, we will talk about the resilient infrastructure. It refers to the systems, physical and organizational, that are designed to withstand, adapt, and quickly recover from the disruptions such as natural disasters, man-made disasters, climate change, cyber attacks, economic shocks, etc. And what particularly if we talk about what makes an infrastructure resilient, that should be able to absorb the shock, that should be able to adapt to the change, and that infrastructure which can be recovered quickly. Discussing about the resilient infrastructure, it is that infrastructure which refers to the system and the structures designed to withstand, adapt, and recover quickly from the disasters. These disasters can be man-made or naturals. There are different types of resilient infrastructures. They are examples are integrated urban water management, flood risk management, green infrastructure, water saving measures, permeable pavements, reclaimed water uses, and flood planning zones. Now, talking about the infrastructure, the importance of this resilient infrastructure, it saves lives, it reduces economic losses, it ensures the continuity of the services like water, electricity, transport, healthcare. It recovers quickly. Whenever any disaster, any natural calamity occurs, it recovers quickly. It supports sustainable development. It enhances community resistance. The characteristics of resilient structures are robustness, redundancy, flexibility, resourcefulness, rapid recovery, reliability, sustainability. If we talk about the resilient structures, we have till now we have discussed the resilient infrastructure, but now particularly in the field of civil engineering, we will talk about the resilient structures. Resilient structures are engineered structures designed to resist, absorb, and recover from the hazards like earthquake, floods, extreme loads, while maintaining the safety and functionality. The types of resilient structures are earthquake resistant buildings, flood resistant structures, wind resistant structures, and resilient bridges and lifeline structures. Now we are discussing the earthquake resistant design. For designing commercial, residential, or any type of building, these are the key principles. These must be incorporated in the design. These are the ductility, strength, stiffness, regularity, and symmetry, lightweight construction. And important design features are shear walls, brace frames, base isolation systems, proper reinforcement detailing, flexible foundations. Now coming to the flood resistant design, if we talk about the flood resistant design, the key design strategies are the elevations, dry flood proofings, wet flood proofing, proper drainage systems, and structural strengths. Structural strength is very important in the case of flood resistant design. Now, talking about the drainage systems are arrangements of the channels, pipes, and structures designed to collect, convey, and safely dispose of the excess water from an area. Drainage system should be designed appropriately. This is the most important in the case of urban flooding also. We will discuss later the case of urban flooding. Now coming to the cyclone design. Cyclone resistant design is the planning and construction of the structures to withstand high wind speeds, heavy rains, and flying debris during cyclones. The key design principles in cyclone design are aerodynamic shape, strong connections, lightweight but strong materials, proper anchoring. And the important design features are roof design, wall construction, openings like doors and windows, and the foundations. Now, for this cyclone resistant design, we have a wind load formula. This is the wind pressure equation. This is P equals to 0.6 V square, where P is the wind pressure in Newton per meter square and V is the wind velocity, that is in meter per second. The wind load depends on the wind speed and exposed area, and it is calculated using the pressure and force equation. This equation in detail is mentioned in IS 875. You all can refer IS 875 for the details of this formula. Now coming to the landslide mitigations. Landslide mitigations refers to the measures taken to reduce the risks and impact of the landslides by stabilizing the slopes. Basically, it is the technique, it is the method for stabilizing different types of slopes, so that controlling can be done on the debris which is flowing during any disaster. That can be natural, that can be man-made also. So there are different types of landslide mitigation techniques mentioned in the figures. You all can refer these figures. Now coming to the landslide mitigation structural measures. The previous slide, this was the general landslide mitigation techniques, but in this slide we will particularly talk about the structural measures. The structural measure which are incorporated in landslide mitigation, they are the retaining walls, rock bolts and anchors, shotcrete, gabion walls, and terracing. The most commonly used structural measure is shotcrete and rock bolting. In the hilly areas, we are facing these two techniques, which are mostly in use nowadays. Now coming to the landslide mitigations, non-structural measures. These are the non-structural measures. They are the drainage control, afforestation, land use planning, and early warning systems. This slide shows basically the slope stabilization. The slope stabilization is the process of improving the stability of natural or man-made slopes to prevent the landslide and soil erosion. There are many techniques which are used for soil stabilization. The methods of slope stabilizations are they are retaining walls, gabion walls, soil nailing, rock bolts and anchors, shotcrete. As I have discussed, the most common techniques for stabilizing soil are rock bolts and anchors and shotcreting. Basically, shotcreting is most important. It is economic as well as most commonly used. Rock bolting and anchors are also commonly used, but they are quite expensive as compared to the shotcreting. Now coming to the slide, next slide, this is the urban flooding. This particular figure shows the urban flooding. Basically, the poor drainage design are the main root causes, as well as the maintenance is also the main cause of urban flooding. Urban flooding is the inundation of lands in the cities due to heavy rainfall, overwhelming drainage systems leading to the water accumulation in the built-up areas. There are many causes of urban flooding. Basically, heavy rainfall, cloudburst is the main cause, but parallelly, if we talk about the poor drainage systems, is also the main cause. That is basically the root cause for the urban flooding. The another causes for the urban flooding are urbanization, encroachment of natural drains, block drains, and if we talk about the impacts of urban flooding, they are the waterlogging on roads, building. You can see in the last slide in this figure. traffic disruptions, damage to the infrastructure and the property, health risk due to the waterborne diseases. Basically, urban flooding directly leads to the health risk. There are many diseases which are waterborne, so it is directly proportional to the waterborne diseases. Now coming to the smart infrastructure, we have discussed resilient infrastructure, we have discussed resilient structures, we have discussed slope stabilization techniques, methods. Now coming to the smart infrastructure. In 2026, this is the most important goal which is given by UN. So smart infrastructure refers to the integration of advanced technologies like IoT, sensors, data and analytics into the physical infrastructure to improve the efficiency, safety and resilience. A smart system must be a asset tracking solution. It should be like city surveillance. It should be like smart parking. These all are the examples of smart infrastructure, like intelligent traffic management, automated monitoring, environmental monitoring, smart lighting, waste management solution, etc. The main key features for smart infrastructures are basically the best. The main feature is real-time monitoring. There are many types of sensors, IoT devices which are used for the real-time monitoring of smart infrastructure, automation and control, data-driven decision making, energy efficiency, resilience and adaptability. The main examples for smart infrastructure are smart traffic management system, smart power grids, intelligent water supply system, smart building with automations. After smart infrastructure, we are coming to the green infrastructure. Green infrastructure means natural infrastructure. It can be semi-natural also, like vegetation, water bodies, soils, designed to manage environmental challenges and provide ecological benefits. There are many green infrastructure mentioned in this picture. You can see one by one. They are non-infiltrating water encourages, vertical green systems, green roofs. Green roofs refers to basically solar roof panels, tree pits, bare earth, trees, urban forest, constructed wetlands, all are the examples of green infrastructure. Now coming to the key components. If we talk about the key components of green infrastructures, they are first, very important, is the green roofs and walls. Second, rain gardens, permeable pavements, urban forest and parks, wetlands and water bodies. The main functions of green infrastructures are stormwater management, flood reduction, air and water purification, temperature regulation. This is the most important. Temperature regulation is the most important, and the biodiversity enhancement. I have compiled the lessons learned in the previous two lectures. The first lecture was on disaster management, and this was on the resilient infrastructure. If we talk about what we learn till now in these two series of the lecture, first we have a knowledge and insights gained from the past disasters that helps to improve future preparedness, responses and recovery. Second, we have learned about the importance of preparedness. Preparedness is very important in disaster management. Third, we learned about need of the EWS. Early warning systems have a main important role in disaster management. We have learned about the effective coordination and communication. We have learned about community participation in the crucial state, and last we have learned about the resilient infrastructure that reduces the losses. Now the most important, as an engineer, what is the role of an individual? The engineering role is very important in disaster management as well as in the resilient infrastructure. Role of engineers basically that is to design a safe system. Engineers plays a crucial role in planning, designing, implementing measures to reduce the disaster risk and ensure resilient infrastructure. These are the emergency planning. These emergency planning tools, emergency planning signs we have I have mentioned here. Emergency planning is the process of preparing the strategies, procedures and resources in advance to efficiently respond to the emergencies and minimize the impact of natural disaster. The community role. The community plays a vital role. It is very important. The role of community is very important in disaster management through participation. Basically, the participation of community is the most important. If every community, every men, women, elders, they must have to participate, because the role of each and everyone is very important in disaster management. How participation importance is, if one participate, that will aware the others also. And the local action before and after disasters, these all are very important. After action is the most important for a community in disaster management. Community role, point wise, I have mentioned here. First is preparedness. Preparedness is to participate in awareness programs and trainings. One must have to participate in awareness programs, to develop the community disaster plans, to identify safe shelters and evacuation routes. And the second point is response, that has assist in rescue and evacuation process, to provide the first aid and emergency support, to share the local knowledge and information. And the third most important is recovery. Community role is most important in recovery also. It is to help and in rehabilitation and rebuilding. It is to support affected families, and it is to restore the community services. Now, these all are the financial tools I have mentioned in this slide. These are the tools which are very helpful in the recovery and rebuilding for community as well as for individuals as well as for states. The very first point is the government funds. Government had kept the particular amount of funds in NDRF and SDRF also. Second, insurances. Everyone must be aware about the insurances. Insurance is the most important factor that can help individuals to overcome the resistance, to overcome the rebuilding and rejoining. The third point is contingency funds. Fourth is disaster risk management. And the fifth is catastrophe bonds. Sixth is international aids and grants. Seventh is micro financial and community funds. PPP. If there are many conditions in which these 7 points mentioned are not applicable, in that conditions, PPP model is very important. PPP means public-private partnership. It is the collaboration between the government and private sector to finance, to design, to build and operate infrastructures or services. Now, these are the Sustainable Development Goals. There are 17 SDGs given by United Nations in 2015 to achieve a better and sustainable future by 2030. There are 17 goals, but goal 11 and goal 13, they are most important, and they are purely in the field of disaster management and resilient infrastructure. Now, if we discuss about this 11th and 13th SDG, the key targets for 11th SDG are to reduce the loss of lives and economic losses from the disasters, to improve the urban planning and housing safety, to strengthen disaster risk reduction strategies, to provide safe public spaces and infrastructure. And if we talk about SDG 13, the key targets are to strengthen the resilience to climate-related hazards, to improve climate adaptation strategies, to promote early warning systems, and integrate climate measures into the policies. Now, discussing about the future challenges, there are many future challenges. The major future challenges are the climate change, rapid urbanization, population growth, environmental degradation, infrastructure stress, technological risk, and lack of awareness and preparedness. If we talk about the resilient cities, what a resilient city can be, it can be that city which can prepare for, absorb, recover from, and adapt to shock and stress such as natural disaster, climate change, infrastructure failure, and social or economic disruptions. There are four, basically, these are the four examples of the cities till now which are considered as a resilient city. They are Tokyo, Rotterdam, Singapore, and Copenhagen, Denmark. Coming to the critical infrastructure. Critical infrastructure refers to the essential system and assets that has an important role in functioning of society as well as economy as well as for a nation. Critical infrastructure has a vital role in sustaining a nation. The major critical types of infrastructure are energy infrastructure, water and sanitation, transportation system, health infrastructure. All examples for these critical infrastructures are mentioned in this slide. We have discussed the different types of disaster. After that, in the second lecture, in this lecture, we have discussed the resilient infrastructure. We have discussed resilient structures. Now, one by one, I want to ask questions. What is the difference between a hazard and disaster? Why do some hazards are not becoming disasters? What factors increases vulnerability in the community? What are the more vulnerable among the humans? What are why the developing countries are more vulnerable to the disasters? What lessons were learned from 2025 Himachal floods? Should disaster management be a responsibility of government? So, ये सभी बड़े important factors हैं, हम सभी को इनके बारे में सोचना चाहिए. So at the end मैं यही कहूँगा भी disaster management and resilient infrastructure are the most important for a country, for a nation, for a state, and for a village, for a city, as well as for any individual. So thank you for watching this lecture. So we will joining soon in the third lecture of disaster management. Thank you, thanks all.